Okay, here's this week's lesson is on projectiles. So obviously we're learning about projectiles. Success criteria, if you can just tick these off as you go through them and you're confident with them, be a good idea. So we're going to define horizontal and vertical velocity. And we're going to look at what vertical acceleration is, and you should be able to calculate distances from horizontal and vertical velocities travelled by projectiles. As usual, the PowerPoints are in there as well. So there's a little starter task. Last week we learned about forces, so there's 15 marks worth of forces starter questions here. Please do these. It should take you about a minute and a half per mark, so around 25 minutes should be enough to be able to go through these. First one is worth 7 marks. So a piano of mass 250 kilograms is pushed up a ramp into a van by applying a constant force of 600 newtons. The ramp is 3 meters long and the van is 0.75 above the ground. Calculate the weight of the piano. That should be easy enough. I've left space down the bottom here for your working. So for your equation, your working and your answer with units, which is worth 3 marks. B, what is the minimum force required to lift the piano vertically? And we put that in bold for you, vertically. And that's only worth 1 mark, so there's no equation there. It's a little bit of a hint. And then C, calculate the work done by pushing the piano up the ramp. We did the work done equation last week, so that should be easy enough. Question 2 is worth 8 marks. A child and sledge are released from point A and go down this hill and they reach a speed of 3 meters per second at point B. The child and the sledge take 5 seconds to get to point B and they're released from rest. So we'll calculate the acceleration. That's for 3 marks. The sledge and the child have a combined mass of 40. Calculate the unbalanced force acting on them if you have the mass. That should be easy enough. 3 marks for that. And then the last part, which is worth 2 marks. After the sledge and the child pass point B, it starts to slow down, coming to a halt, completely at rest at point C. Explain this motion in terms of forces. So you need to describe the forces that are in play from when it passes point B till it gets to point C. Remember Newton's first law, something will stay at rest or at constant speed until an unbalanced force is acting on it. So if it's going from a constant speed all the way down to rest, then an unbalanced force has acted on it. So describe what that might be and the forces that are in play, and put your answer in the bottom. Right, so task 1 is you're watching this video, and the PowerPoints are also there, and then just take some notes in your jotter. That should take you around 45 minutes. And the notes are also below here if you want to have a read at them. Task 2, therefore, after that's going to be tutorial questions again and another assignment, 40 minutes, and past paper questions around 45 minutes. That should cover your 5 lessons for this week. Right, so let's talk about projectiles. A projectile is any object that is only being acted upon by the downward force of gravity. We all know gravity acts downwards. It's the force that keeps us on the ground. And we all know that that's 9.8 meters a second every second. So 9.8 meters squared. Now, to be able to understand projectiles, you need to know the difference between horizontal and vertical. Horizontal is when something goes left to right, so that's a horizontal, and vertical is up and down. They are totally independent of each other and they are both calculated individually and separately. Right, let's look at an example. So horizontal, first, a car, it'd be easy enough, a car travelling at a constant horizontal velocity along a straight road over a course of time, let's say it's 20 meters per second, over 4 seconds. So here's the velocity time graph of that. It's a constant speed, constant velocity of 20 meters per second over 4 seconds. So therefore we can calculate the distance that that has travelled by doing the area under the graph. Area of a rectangle, base times height, 4 times 20 is 80 meters. Let's look at vertical. Let's say you're on a cliff edge here and you have a stone. If you let that stone go and it only takes 1 second to reach the bottom, 1 second, then before it hits the ground, that stone will be travelling at 9.8 meters a second. If, however, that stone takes 2 seconds to fall to the ground, it would be 2 times 9.8 meters a second. Likewise, if it took 3 seconds, it would be 3 times 9.8 meters a second, because gravity is pulling us down at 9.8 meters every second. 9.8 meters a second every second is what our velocity increases at. So if that stone takes 5 seconds to reach the ground, 5 times 9.8, 49 meters a second is what that speed of that stone is going to be travelling at just before it hits the ground. And it's really important that here we are ignoring air resistance, which is always present, but for these calculations we are assuming that there is zero air resistance. So let's have a look at the velocity time graph for what we've just talked about. So I've already said every second it gets to 9.8. We've just rounded it to 10 because it's a bit easier for a graph here. So after 2 seconds it's 20, but it's really 2 times 9.8. 3 seconds. You can see every second the speed increases. So after 4 seconds it's really going at 40 meters a second, just below 40. So again, if we want to calculate the area that's covered, so if you wanted to calculate the height here, the height of that cliff, and all you're given is the time, and you know gravity is 9.8, you can calculate the height of that hill by doing a half area under the graph, a half times base times height. So here it would be a half times 4 times 40, 80 meters. Okay. Right, horizontal. Let's just split this up into two now. Horizontal velocity. We give it a little subscript. That's the right word. Horizontal velocity is the displacement divided by time, and that's also horizontal. I'm going to highlight that. Horizontal must go with horizontal. So if you're trying to calculate the horizontal distance, so the distance horizontally, you need the horizontal speed times time. Again, horizontal is in both these equations. Now, vertical is a little different. If you want to calculate the vertical velocity, so VV, vertical velocity, we use our acceleration equation rearranged. V equals U plus AT. And for vertical velocity, the initial speed is always 0 meters per second. The acceleration is the acceleration downwards, remember, because it's vertical. and our acceleration downwards is gravity, which is our 9.8 meters a second squared. Right. Let's look at an example. A ball is kicked horizontally at 5 meters per second. So it's being kicked off a cliff at 5 meters per second horizontally. It takes 2 seconds to reach the ground, so it is going to follow that path. So it's been kicked horizontally, and the time equals 2 seconds. So part A is calculate the horizontal distance. So the horizontal distance, you need the horizontal velocity, which we have, times by the time, which we have. So it's 5 times 2, 10 meters. So that distance there, the horizontal is going to be 10 meters. Right, part B, what is the vertical speed just before it hits the ground? So using the equation that we've already done, vertical velocity is u plus at. Vertically, the initial speed is 0. Acceleration is due to gravity, 9.8, and we know it was in the air for only 2 seconds. So 19.6 meters per second. If you want to calculate the height, we're going to, you can draw, but our velocity time graph. We want to know the vertical height. So in order to calculate that, we have to use the vertical speed, vertical and vertical. And the only time mentioned in the question was 2 seconds. So 19.6 was the vertical velocity. The time was 2 seconds. In order to calculate the distance or the height of that cliff, it's the area in here. So again, a half times 19.6 times 2 just happens to be 19.6 as well, and 19.6 meters is the height of that cliff. Okay, hopefully you're okay. Let's do another example, make sure we're consolidating our learning good enough. This time it gives us the height. So on a TV game show, contestants are challenged to run off a horizontal platform and land in the rubber ring floating in the swimming pool. It's 2.8 meters high. The contestant has a mass of 60. So he runs off the platform with a horizontal velocity. So VH equals 3 meters a second, and then follows that path. And it takes 0.85 seconds. Calculate the horizontal distance. So horizontal distance, you must use the other thing that's horizontal, the horizontal velocity times the time. 3 times 0.85, 2.55 meters. So x there, 2.55 meters. Calculate the vertical velocity. Vertical velocity u plus at, 0 plus 9.8 times 0.85. So if he's not even been in the air a second, he will never reach 9.8. So you know the number is going to be lower than that, and it happens to be 8.33 meters a second. Right, part B, another contestant has a mass of 70, so the second contestant weighs 10 kilograms more. Will he need to run faster, run slower, or the same horizontal velocity as the contestant to land in the ring? explain your answer. I wanted to do this with a diagram. Effectively, the mass has absolutely no effect. It's only gravity that's pulling you down to the ground. And I've set up this little diagram here just to explain it a bit more detail. Let's say you're up the top of a building here. Again, we're ignoring all air resistance. You're up the top of a building here, 400 meters in height. You have a golf ball, a football, a car, and let's say you could carry the moon, you're Superman. If you were to drop all those at the same time, in which order are they going to hit the ground? So most people would probably say, well, the moon is going to be first. That's going to hit the ground first because it's the heaviest. The car's probably going to be second. Possibly the golf ball third because there's no air in it, and maybe the football would be last because it's filled with air. So we are ignoring air resistance. Okay, the answer actually is they are all going to hit the ground at exactly the same time. And I'm going to explain why. The mass has absolutely no effect if we ignore air resistance. So if we think about let's say that the person is just holding the golf ball, they're holding the football, they're holding the car, or they're holding the moon at a certain height. That golf ball, football, car, or moon is going to have potential energy. But when that golf ball, football, car, or moon gets released, all that potential energy is going to change into kinetic energy. So we know potential energy is mgh, you know that from your equation sheet. And we also know that Ek, the kinetic energy, is a half mv squared. We have an m on both sides, so we can just cancel the m's out. The mass has absolutely no effect on it. So gh equals a half v squared. If we times both sides by 2 to get rid of that half, we have 2gh equals v squared. So v equals the square root of 2gh. If you want to calculate the speed, it depends on the height. So we have 400 meters. It depends on g, which is gravity. If you're on Earth, just be careful of the question. It might say you're on Earth, it might say you're on another planet. If it says you're on Jupiter, remember and use the gravity number from your data book. All times by 2 and then square root at the very end. Mass has absolutely no effect. It only depends on the height. So all these 4 items, the golf ball, the football, the car and the moon, will all reach the same speed before they hit the ground. V equals the square root of 2 times 9.8 times 400 meters a second. Whatever that number gives you, x meters a second, they will all reach that speed. That's if you're given a distance in the question. If you're not given the distance in the question, what they will give you is a time. So let's say that took 9 seconds. The golf ball, the football, the car and the moon were all timed, and it came to 9 seconds. Before you release it, the initial speed is 0 still. We know the time took 9 seconds, and we know A, which is the gravity, which is 9.8 meters a second squared. So we can calculate V. V equals u plus at, 0 plus 9.8 times 9 0.8 times 9, 88.2 meters a second. And I'm just going to go back and do this one, make sure it comes to the same number. 2 times 9.8 times 400, square root of 7,840 is 88.5 meters a second, 88.5, 88.2, same number, same speed, doing it two different ways. So that will just depend what the question gives you. If it gives you the height, then you would need to do it this way. If it gave you the time, then you would do it this way. Right, that pretty much covers projectile lesson. Now you need to go on to the tutorial questions, and you need to go on to the past paper questions after that. There'll be a live lesson Tuesday and Thursday as usual next week for my class, and you will also be in school. Good luck.